The planning experiment questions, we did the first two questions. Question one was related to how the insulation can affect the rate of cooling. And the second experiment was investigating how the resistance of a wire depends on the length. Okay. Question three is related to the lens topic that we will do later. So we'll skip question three right now and we'll move on to question four. We will do, but later, not now. So as I mentioned, whenever you're planning experiments, especially in physics, you, instead of writing the whole paragraph, try to answer each point separately according to the, so you will not miss anything. So the experiment, a student is investigating resistors connected in parallel. When the student investigating resistors are connected in parallel, the following apparatus is available to the student: an ammeter, voltmeter, a power supply, variable resistor, switch, connecting leads, a box of identical resistors. Like he's having lot of resistors are there identical, but all of them are same. Plan an experiment to investigate how the combined resistance of a resistor connected in parallel depends on the number of the resistors. Like if we change the number of the resistors in parallel, how the resistance is affected. Look, we know that if the resistors are connected in parallel, we are using this formula, the RT is equals to 1 over R1 plus 1 over R2, or if two are in parallel, it will be a product divided by sum. But we don't have to write this formula at all, because we have to investigate, like practically, we want to find that how the resistance is affected by the number of the resistors connected in parallel. To get the resistance of any circuit, what you need to get or to find the resistance of any circuit, what you need the voltage of the components across the components, and you need the current. So to get the voltage, what we need a voltmeter. To find the current, what we need an ammeter. So voltage divided by current will get the resistance. So we want to investigate how the resistance of the circuit changes as we change the number of resistors connected in parallel. That's the main experiment. So whenever you write the experiment, you, as I mentioned, especially for physics, you will always write the experiment, try to answer each point separately. Okay. So first one is draw a diagram of your circuit you could use to determine the resistance of resistors connected in parallel. Show only two resistors in your diagram. So we have two resistors which are connected in parallel. So we draw two resistors in parallel. If I want the total resistance of these two resistors in parallel, so I need a voltmeter. How we connect a voltmeter? In parallel to the component or in series?
Parallel.
Parallel. So voltmeters are always connected in parallel. And because we know that voltage is same in parallel, so we connect a voltmeter. You can connect anywhere. You can connect above the, like top of the first one or the bottom or in between. It does not make difference. Then we want to measure the current. To measure the current, we use an ammeter. And how ammeter is connected? It is connected before or after or in series to the component. Then we have a power supply. So this is a circuit symbol for the power supply. We should have a switch as well. Why we should have a switch? So we can switch on and off this circuit control. And then to repeat the experiment for the same values or different values, we should have a variable resistor. So we can repeat the experiment. Otherwise, what will happen if I have only a power supply? If I have only a power supply, I'll get a single value for a voltage and I'll get a single value for the current, and I cannot repeat the procedure for this circuit. So what we need a component to repeat our experiment, because whenever we repeat the experiment, we can identify the anomalous results, the results which are not in the range or order. So we should always use a variable resistor. We can change the power supply, that's right as well. We can change the power supply, or you can also use a variable power supply. So what is the circuit symbol for a variable power supply? So you make an arrow for the power supply, that is a variable power supply. So practically the simple way is make the constant power supply and use a variable resistor. So as you change the voltage and current in the circuit, resistance does not change, but the values of a voltage and current will change, and we get different the same ratio as the resistance is constant. So plan an experiment. The first, draw a circuit diagram to determine the resistance of resistor. So it should always be labeled. Like I should label each. I did not label, but here is a variable resistor. Here I have a fixed resistor. Here I have a voltmeter. Here I have an ammeter. Here is a power supply. Okay. Don't write in short. Write the full form for these each symbol, and then we have a switch. Explain briefly how would you carry out the investigation, like the procedure. The experiment is about how the resistance, we want to find the resistance of a circuit, how it is affected by number of resistors connected in parallel. Like if we have two resistors in parallel, we work out the resistance, then we will add another, we work out the resistance by measuring a voltage and current, and then we do it for 5 sets or 6 sets of results. So experiment is investigating how the combined resistance of a circuit is affected by the number of resistors connected in parallel. Now the second point, explain how would you carry out this investigation? How will do this experiment? That's the second thing. So the best thing you can mention, connect the circuit as shown in the diagram. We connect the circuit as shown in the diagram, or connect first two resistors in parallel. Then we connect voltmeter and ammeter. We record the voltage and current. And we'll find the resistance by using a formula R equals V over I. Then we repeat the experiment. Don't mention only repeat the experiment. Just mention the number of the time, how many times you will repeat the experiment. Like repeat the experiment 3 times is the minimum number you should repeat. Then repeat the procedure by adding another resistor in parallel, and then repeat for 5 sets of resistors. Like first we have 2 in parallel, then 3 in parallel, then 4 in parallel. So we repeat for 5 sets of results. Then draw a table or tables with a column heading. Column heading means like it should have a units. So what are the like what will be the table looks, how the table will look like? First thing, we'll have, you're not supposed to write any values. You're not, just the quantity and the unit. For example, we have a number of resistor. I'm writing in short here, number of resistor. Number of resistor, like first in parallel, first we were having two in parallel, then we have three in parallel, then we have four in parallel, five in parallel, and six in parallel. As I mentioned here, we repeat for five sets of resistors. So five we kept in parallel. And whenever you're doing the experiment related to electricity, what are the precautionary measures you should take? You should switch off the circuit between the readings, because if a circuit is remained on for a longer period of a time, it will produce a heating effect, because the current is having a heating effect. So switch off between the readings, or use low power supply, low voltage power supply, to minimize the heating effect. So these are the things, this is a common thing which you should have for electrical circuits. So number of the resistors which are connected in parallel. Then what we are measuring a voltage. So we are not supposed to write the complete voltage. We can just write capital V for a voltage, and then slash the unit of a voltage is volt. So that's also represented by V. The next we are measuring a current. So we mention a current is there, which is current is represented by I, and the unit of the current is ampere. That is what they mean here. Table with a column heading means the quantity and the unit. So what quantity we have? Like we have a voltage, current, that's a quantity, and the unit of a voltage is volt, unit of the current is ampere. If the circuit, if it get too hot, the resistance of the circuit will change, because the temperature can affect the resistance of the circuit. That's why it should not be too hot. So number of the resistors, voltage, current, and then we are getting a resistance. So quantity is the resistance and the unit is ohm, which is represented by omega. And you're not required to enter any readings on the table. Like even if I write here 2, 3, 4, because it's a common, like according to the question I write, it does not score, or if I don't write this, I will not lose any mark. So table with a column heading means like a quantity with its unit. But number of resistor does not, it's just a number. So that's why I did not mention any unit there. You can have one table and representing all the quantities there, or you can have a separate, like you can have a VIR columns for 2 resistor, then for 3 resistor, then for 4 resistor, and so on. So that's how this experiment is done.
Hello?
Yes.
Okay, so what if you do not use a variable resistor?
If you don't use a variable resistor, then you can get this answer. You will find the voltage and the current, but you will have a single set of values or a voltage and current for each combination. Like you cannot repeat your experiment. I'll show you the marking scheme, like the points which will score the marks. Look, that's how the marks are distributed. Okay. Yeah, sure. I will draw the diagram again. So first thing is, the first marking point on a circuit diagram, one voltmeter in parallel with any component, like first resistor, second, as I drew the voltmeter. Then a circuit diagram correctly shows a power supply. So I should have, because the circuit symbols are important, power supply, ammeter should be there. Here, correct symbol. So correct symbol for ammeter, voltmeter, and the fixed resistor. So 3 marks 3 marks are there. You will score from the circuit symbol, like the drawing the circuit itself. And how we do, like example, we have two resistors in parallel. If you don't repeat, like in this case, as it did not mention any point related to a variable resistor, so you won't lose any mark. But why I say, because practically repeating experiment identify the error. So practically you should always repeat the experiment. That's why electrical circuit, we always use a variable resistor. Even though if you don't write a variable resistor, you will not lose a mark. Okay. So that's how the circuit will look like according to this part. But if I mention a variable resistor
Okay.
repeating, that's fine. So repeat with different number of the
Okay.
resistors in parallel, as I mentioned. Then table that includes the column with the number of resistor, voltage, current. Then marking point 6 and 7 are, as you can see here, the marking point 6 and 7, how resistance is calculated may be shown in the table. Like how, as I mentioned in the procedure, we calculate the resistance by voltage divided by current. Use at least 5 different combinations. Repeat with different current or a variable resistor setting. So here, one of the mark, as you can see here, you can get the 6 and the 7 marks are not fixed. Like there are 4 points which can give you, out of 4 you can write any 2 and you will get those marks. But variable resistor point is also included there. Okay. So repeating with different current and voltage settings or using a variable resistor will score a mark if you miss any point. Drawing a graph with a number of resistors, again, the combination, that's how we represent our result. Is it clear? Anyone having a doubt or a question in this experiment?